All right, welcome to the help session. So in this help session, I'm going to spend a little bit on the assignment if there's any questions. I have already covered the whole assignment, so there's not much more I can cover without giving away the solution. So I will go through a couple of things though in the assignment just to clarify some stuff and just some cool tricks that you can do as well to just improve some concepts. So the first question we have is possible solutions for segmentation fault. So segmentation fault is, there's a couple of ways to debug. So just to see what a segmentation fault, let's look at the most basic example. Before I go any further, so anyone that's new, it's kind of expected that you use the chat and you respond by just saying yes or no or agree, just so I know that people are listening along with me, because it is hard just talking to yourself. So try and interact as much as you can. The second thing is, well, that's the main thing actually. If you're not sure where the chat is, it's in the YouTube window on the side. So please use it and ask your questions. So someone asked about possible solutions for segmentation fault. So let's quickly go into what is a segmentation fault. So let me just get rid of this. Put that there. So basically what a seg fault is we saw, did it again. Sorry, I'm just trying to get the right windows up. Okay, so in, I think it was lab 5, we saw we had this big block of memory and we had parts that were legal and parts that were illegal. Okay, so let's say the sad faces are illegal and the happy faces are legal free memory or our memory. Okay, so basically a segmentation fault is if you try and either read or write into one of these spots. Okay, now because the compiler has no clue where these are going to pop up, nor how you're going to use your memory, it can't give you any information about you accessing illegal memory. So let's have a look at the most simplest case. So the most simplest case of a seg fault would be something like this. Int x5 where's my eraser not working? And we go x 800 becomes 2. So this would be a segmentation fault. Likely, unless by chance this is free memory. But this would likely be a segmentation fault. So we have 5 spots that are ours, but we're going to some random spot in memory and accessing the 800th spot. Now the compiler can't pick up that you're doing this because this subscripting is really just this. And so the compiler doesn't know that this array is 5 long. Okay, and that's why it doesn't know about this, right? And the same with negatives. It doesn't really know what you're trying to do in a lot of cases. Just want to make sure, you can all hear me, right? Just wanted to double check. So the other case for a segmentation fault would be int wx 2000 whatever. And this is just reading it. So you're reading here. Okay, so it's not just writing, it is reading as well. So we could also get a segmentation fault from doing something as simple as int star w, and this pointer could point at some illegal spot or not. We don't know. It hasn't been initialized. So having a pointer that points at something illegal is fine. And sometimes you actually need to do that just for optimization. So you know it's pointing at something illegal, but you just don't read or write to it. As soon as you read or write to it, that's where the dangerous part comes in. Pointing to something illegal isn't going to hurt, okay? You try and avoid it because it's not doing anything useful, but some cases where you're iterating, you may end up pointing just after the array. So with this, we have the same problem. So if we go, let's say, int p star w, okay? So you are now trying to read here, okay? So this could result in a segfault. However, one thing okay, so someone said they don't understand what read or write. So let's go back a step. So int a equals 4. So 4 is being written into a variable a. Int b becomes a. A is being read from memory, and it reads it, and it gets a 4, and then it's being written into b. So let's say this spot in memory was b, then a 4 would be here, and let's say a 4 is here for a. It would read this spot, and then it would write it here. Okay. So my question to you is this: int star a, and what I'm going to do is int star b becomes a. Now, with this segfault, is this dangerous? Does this have a chance of segfaulting? And why? So if you don't know, just say don't know. It just keeps the flow going. Just be honest or have a good guess. So we saw that beforehand I had int star a, and I had int w becomes star a, and I said this has a chance of segfaulting because, now I've lost where we are. This has a chance of segfaulting because we follow the pointer and we grab the value that it's at. But what about this case over here? You're all still there. So if you're there, if you don't know, just say don't know. I just want to see. Okay, so this won't have a chance of segfaulting because it is copying the pointer. The pointer is legal memory. What is pointing to could be anything, however. Okay, so it's copying a memory address. All right. Now a memory address is not reading or writing into memory. It's just grabbing this So it's reading the pointer's value, but it's not writing into anywhere, or it's not reading anywhere. Because we dereference here, we're actually going to that random value and reading it. Here, we're just copying some random value that's a memory address. So this won't segfault, even though it's kind of stupid, because you're copying a pointer to some invalid spot anyway that's uninitialized. And you will actually get a warning here that says A is used uninitialized in this function. Okay, but that won't actually segfault. It may cause issues later down, but unless we dereference the pointer, so if we go there and read the value, or go there and write to the value of where it's pointing, then it has a chance of segfaulting. Now I say a chance, okay? Okay? With segfaults, it may be the case that you get it 1 in 10 times. It may be the case that you get it in 1 in 1,000 times. It may be the case that you get it in 1 in 100,000 times. The more likely case, so the higher this is, generally the further you're going away from your arrays in the stack and things like that. Because usually you're gathered around a certain part of free memory. So if you're getting a very high segfault rate, so if it sometimes works, I mean, if it always segfaults, then the issue is probably quite large. If it's happening not so often, this is actually worse because it means that you don't know when it's going to segfault, so it's harder to debug. This one's a lot easier. It always segfaults. Because it's always segfaulting, you can quickly find out where the issue is. This is the harder one. Okay, and this one is usually when you go 1 past the array. So because your variables, your arrays, sorry, when you create a fixed array, so int x4, if you go x4 becomes 3, it actually doesn't have that high of a chance to segfault because this memory is all together in the stack. It has a lower chance to segfault. But doing something like 400 here actually has a higher chance. So generally, if it's this case, you've got a condition where you're going deep into memory, or you've got an infinite loop. So what I see a lot of people do, and this guarantees that you get a segfault. So let's say, I'm going to do a little bit more of a realistic representation of memory. So let's say all this green bit up here, I'm pretty sure I've chosen a better color. Let's say all this purpley blue stuff is legal, and let's say this is illegal memory. Now what you'll see a lot of people do, and when they make a mistake, is they will have an infinite loop that iterates over everything. So it won't segfault, 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 and then it'll reach here and segfaults. Because they've got an infinite loop or a very, very long loop, it means eventually it has to reach something, and so you get this 1/1 case where it always segfaults. So, ways of debugging segfaults. The first one, which is the easiest, is using GDB, and this is on LMS. Okay, and there's instructions there on how to use it. The second way, which is probably the second easiest, is draw out box and pointer. It's not as powerful, but it ensures that your logic follows your so this one's great and it's very powerful. So it's great for finding the error, but this one is great for finding the logical error. Okay, so if your problem is that, let's say, you created an infinite loop or you did something silly with syntax, then GDB is going to be great. But let's say it's something about your logic. So let's say you decided, oh, then for some reason there must be 5,000 components for every component the user enters, or something silly like that. So you're going to find that with your logic. Okay, if your logic's wrong, then the debugger can't do anything. The logic is based on your intelligence and problem-solving skills to solve a problem. If it wasn't, then programs would just write themselves. So you do need to do this. The third way is index tracking. So you'll find that most of your segfaults are due to arrays. They don't have to be. But you'll find for most students, because you're traversing an array, that's where you're going to get the most segfaults. So what you can do is use printf, and everywhere you basically use an array, you always print out the index. So let's say I had a for loop, blah, 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 and I had, I don't know, printf x, I don't know what I'm doing. Let's say I had a for loop, and inside that I had %d xi, okay? Then, because I've got this xi here, every time I see this, I print out %d and the I. Okay? So I track the indexes. Now with pointer arithmetic, this is a little bit more difficult because you've got an iteration variable. However, we have a little trick we can do. So what we can do if we're using pointer arithmetic, so let's say I've got a for loop and I've got this X array, and I go int star X iteration becomes X. Well, what I can print instead, if I'm using X and I'm going X iteration plus plus like you saw in the labs, so this is the kind of pointer arithmetic you should be doing. It's creating a place to store it and then adding them up as you go. This is what you should be doing in the assignment. So let's say we use this variable somehow. Let's say x itr becomes 4. We just set everything to 4. Now, what I can print is kind of interesting. Actually, I should check something before I do that, because I'm not sure if it's legal in this version C. Give me 2 seconds. Cool. Right. So I'm just going to very quickly test something. I want to see if you need C9. I think you do. And not the font specifiers for this. So what you can do is I can put %d here, and I can go x. Actually, I want to go xitr minus x. Okay, now this may seem strange because I'm subtracting 2. Okay, so what this is doing is, let's say, I'm actually going to change this to a short, because if you worked out by now, I like shorts for doing this. And we've got short x5, okay? So in memory, actually I'll change this to 3, okay? And this is a for loop, I equals 0, I less than 3, I plus plus. So I've created a short iteration variable. I've got my for loop, and I've dereferenced xitr and set it to 4. And then I've printed out this xitr minus x, and then I've incremented xitr. So everything you've seen before except for this minus. So I'm going to create x in memory. So we get these 3 spots. And let's give some memory addresses here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E. Now, what we know is that x actually has this pointer that points to the start of the array. Okay, so there's a pointer here that holds 0, and this is x. We also have another pointer which is called xitr, okay? And this also holds 0. So address 0. I'll put A0 so that makes sense. So xitr minus x is 0 minus 0. Okay? So we end up with 0 here. So we're talking about the 0th index, even though we're using pointer arithmetic. Now, we come here and we increment xitr. So we add 1, which we know is 2 in this case, because we're using a pointer, which is a type short star. So it goes up to here. Now, when I go 2 minus 1, what you would expect to happen is you'd get, 2 minus 0. What you'd expect to get is 2, but what you get is actually a 1. Okay, this isn't going to be tested because we haven't gone that far into pointer arithmetic, but you actually get a 1 because basically now you're dividing by the size of. So this is 1 spot, and this is 0 spots away from this. So it's 1 jump away. And so you'll actually get a 1 here. So it'll tell you you're talking about the first index. And then on the next iteration, you'll have a 4, because this goes up by 1, which is 2 plus 1 is 4, as we learnt, because we're talking about shorts. And so 4 minus 0 actually equals 2. So this is a little bit confusing, but we still can do index tracking using pointer arithmetic. Okay, pointer arithmetic is quite powerful. You won't really see the power in this subject too much, but we can do tricks like this, which can make C very powerful. Does that make sense? My phone's going crazy. So just say yes if that makes sense, or if you want something really clarified. I'll just check. So what I'm explaining at the moment is different ways you can test for segfaults. Okay. So we're just looking at index tracking using pointer arithmetic. So that's pretty much index tracking. That's one way you could do it. Now, another way, which is probably the most difficult way, and I wouldn't recommend it, but it may help certain people, or if you've got a very small amount of code, but it can be difficult. And this is address tracking. So what you do here is you use your %p to basically print out all the addresses of everything, so all your variables, and then you test everywhere. Before you write to a spot or read from a spot, you print out its memory address and see if it's in your space. Now you can actually write a function to do your address tracking. So what you do in your code is you write a bit of code to create an array of addresses. Okay. Then before you call your function or use something, any variable, you can actually use the search function you did in the lab to do this as well. It's not very efficient, but you call this function, well, not that function, but you grab this array from another function and you search, is my address in the address space that I'm using? And if it's not, then you know there's something wrong. Okay, so if you get some address that is not one of the addresses of your variables, you know that's where you're segfaulting. This is a tricky one to do, but if you do it right, it can be quite helpful. You can also do address tracking by hand, but remember that if you run your program again, it's going to change the addresses. So doing it by hand is kind of bad. I would actually write a function to do that. This is actually better than GDB in some cases, because GDB will only grab the error if it segfaults. So if there's a 1 in 1,000 chance that it'll segfault, this will actually always grab it. Okay, so this is a good way for always getting unsafe spaces, but it is a lot of code that you need to write and a lot of debugging. So unless you really want to ensure everything works, I wouldn't recommend at this stage going down that path. And I don't have anything pre-written to do that. I might actually write something up to show you what I mean. Not now, obviously, but I might give you a tool on LMS to help you with that. But address tracking is quite helpful. Index tracking is good, but it only really works for arrays. Address tracking will work for everything. And index tracking can sometimes get difficult with pointer arithmetic, as you saw. Further than that, these are probably the main ways. Most people are going to go with GDB. I highly recommend you draw out the box and pointers. Index tracking, I also recommend. Address tracking if you really want to make sure things are safe. Now, one other thing that I don't know if I mentioned last time, the other thing you should do is also check for null pointers. So when you call your malloc function, what a lot of people forget to do, and I haven't specified it there, but if you have your malloc function, and let's say we're doing something similar to the lab, and we've got, not lab, assignment. Let's say we've got something like that. Okay, size of int times w. Now, this is well and good, but there's one big problem here. Can anyone guess what the problem is? It'll still work 99% of the time, or even higher than that. Well, actually, I kind of lie there. It depends on the situation. But what's the case that this doesn't work? Or even, it doesn't have to be this. It could just be int star a malloc size of it times p. So it won't allocate illegal memory. Malloc won't do that. So that's not the problem. So the problem is, actually, so what I recommend you try is put a very large number in here. Put, I don't know, 100 megabytes or maybe even higher than that, a gigabyte of memory. Now, you may see loading. So if you put a gigabyte here and you look at your memory usage of your program, you may notice that it doesn't actually use a gigabyte. What you need to do if you actually want to use that full gigabyte is actually start writing into it. So it's just a way of the computer doing some optimization. So if you do want to try this out and see what happens when you run out of memory, there's a couple of things you can do to enforce that it does run out of memory. But if there isn't enough memory on the computer, we have a big problem. Okay? Basically, if we don't have enough memory, then our program should really shut down. Okay? As much as we don't want a program to crash, if the hardware can't support our program, it is pointless running the program. Okay? So, if you don't have enough memory, what malloc will return is null. So what you should really be doing here, and I'll just show you one thing as well, which you haven't seen much of in this subject, but you might enjoy it. So let's say I have let's say I have int a, and if I go, if a becomes 4 is equal to 0. So you can actually do assignment and equations in the same if statement. It just means that this will execute first and then it will compare a with 0. Okay, which will give 4. Which will give false, sorry. Okay, so we can actually do assignment and expressions in the same block. However, I'm going to not do it that way for simplicity's sake. So xi is a pointer, by the way, as it is in your function. So I can do x if xi equals 1. No, not 1, sorry. What am I doing? Oh my god. If this is null, oops, I'm going to grab this. No, give it to me. So if this is null, then what I'm going to do is just exit 1, okay, or return 1 if you really want. The reason being is, and you might want to print a message to the user to say, you're out of memory. You probably wouldn't in most cases print message because most stuff's automated, but yeah, if you run out of memory or there's not enough memory to malloc, you're better off just ending the program because there's not much you can do. If you don't have enough memory, then you don't have enough memory. And if your computer's, or if your program is getting to the state where it doesn't have enough memory to run, then it's probably not worth trying again or trying to do something. If you've got a more critical program, you might pause the program and send a message to the user, please try freeing up memory and then try again or something like that. But in most cases, if you're running out of memory, there's something serious going on and your program's probably not worth running. And you will see this with traditional programs as well. Okay, so if you open, I don't know, some program, let's say SolidWorks, if you don't have enough memory, it just won't run. Because it just goes, well, this is going to crash anyway, or not be able to run, so it's kind of pointless running it. Does that make sense? And so the same thing here, we can just put an if a equals null, then we exit the program. Okay. So just to answer if it makes sense. Cool. Yeah. So what I'm going to look at now, it's just a concept that I think you might find helpful with the assignment. It's not overly helpful, but it's just kind of an application of an array. So let's say I have an array and it has ints in it. And let's call it X. Okay? And it's of size 5. All right? And it has the values 1, 3, 2, 1, 2. So in a lot of languages and in a lot of problems, there is problems with mapping. Okay? So mapping something to something. Now you've got this problem in your problem already. So there's a couple of ways you can go about mapping. So when I'm talking about mapping is, let's say a 1 represents 84, a 2 represents 106, and 3 represents 42. And you're trying to find the relationship between them, because if you can find the relationship, then you can write a function rather than writing if statements. Now, another kind of mapping might be numbers to letters, which you do have in this problem. So let's say a 1 is an A 2 is a C, and a 3 is a F. Okay, so let's say E actually. Okay, there is actually a really nice way to go across this mapping, but I'm going to do it the slower way, just for something that you might find interesting. So I could create a character array, and I'll call this letters or something. Okay, and I'll say it's 3. And then in this, I'm just going to write A, C, and E. Okay, so now what I'm going to do is do a for loop. I'm going to go I 0, I less than 5, I plus plus. And in this for loop, I'm going to put a printf. And now that I've got my, basically my map to whatever these values are, and it doesn't have to be as simple as this. I'm just doing a very similar example. So I'm just going to go %C here and a new line. Okay, let's say in this example. And what I'm going to put on this side is something like X, not X, sorry. I'm going to put letters X minus 1. Sorry. I'm going to put letters X I minus 1. Okay, so this is not the best way to map it, but it is a way to map it. And it's fairly clever. It's not the ultimate solution. If you could write a function here, and I mean a mathematical function, not a C function, is what I mean by that. So here, let's see what happens. So I is 0, so let's just say I is 0. So x0 is 1. 1 minus 1 gives 0. Letter 0 is A. So the first letter that's printed is an A. We then increment I, and we get a 1. X I is 3. 3 minus 1 is 2. Letters 2 is an E. And you can see what's happening here. So we get a C, an A, and a C. Okay? So without if or else's statements, we've basically just turned that into one statement. And we've got rid of the if, else if, else if, else if. Because comparisons are actually kind of expensive. If you go on to do more algorithmics and stuff, if we can avoid comparisons and rather write something that maps something to another thing, it's a lot faster. Because here it's just a couple of operations. So subtraction and plus are very cheap operations. Multiplication and divide are actually expensive. Searching for something is really quick. So this is actually really quick compared to if x I equals 1, because we've got one read there, we've got another read, we've got a comparison, and then we've got whatever happens here, and then we might have multiple prints versus something quite nice. So I just thought I'd show you that. You don't have to use it, but for those that are up and ahead, there's something you can do. Does that make sense? All right. So what I'm going to do now is find it. What is the assignment? So look at that. Put that in here. Here. Oh. I think. So there was one other thing I wanted to check. Yeah. So someone pointed this out earlier today. It appears that for some reason, I don't even know how that's possible, there's a small mistake on the assignment sheet, which I don't even know how. So on the output examples, okay, we have this third case here, all right, which looks something like that again. So I'll fix this up in a little bit. So if you're using the examples, use the ones on LMS. The one on the assignment sheet seems to be wrong. I don't know how that's even possible, because they were both generated the same. It might have just been something else that happened along the way. So if you have a look at the assignment sheet, so I just think I should point this out. You'll notice that there's a small problem down here. So this should be +1 here, and this should be +1 here, and this should be minus. For some reason, the example output on the assignment sheet is just showing zeros, which is very odd because all the math still works out. So I don't know what's happened there. I have to go back and have a look, and I'll fix that up. Okay. So just be aware of that. I don't know how that, because it doesn't even make sense, because the maths shouldn't work if they weren't the correct values. So yeah, that's a little odd. So just be aware of that. If you are looking at that example, use the examples on LMS. They all look fine. I will fix that up. Don't know how that happened. But anyways, I don't plan on going over this too heavily because I have given you a lot of the assignment, and I need to ensure that there's some parts that you do understand by yourself, and just seeing the difference between people's problem-solving skills. But this is basically the last part, and difficult given what you've done so far. If you've done the rest, this is just your components table with a couple of other things. The spacing, you're just going to have to either trial and error or calculate. So you can calculate it based on the width of these, or you can just try trial and error. Now, some people asked, how do I go down the page? You don't. You go across, then you put a new line, you go across, and you do a new line, then you go across, and then new line, and then go across, and new line. So it does mean that we have a little bit of some problem solving here, and I'm not going to give it away, but you are counting up, and then you're counting up again, and then you're counting up again for each component. And there is a really, really easy way to do this, okay? So if your problem-solving skills are good, you should be able to do it really easy, and there is also, if your problem-solving skills are bad, there is a slow way to do it, but it will still work. And you can basically hack it if you want to get it out, but it won't be as good of a solution. Okay. So I'm going to leave that one up to you unless there's some specific questions about that. Furthermore, there is a bonus, if you haven't noticed already, and that's basically printing these signs outside of the bracket, okay? Which isn't too difficult, but it's harder than you think it is. Okay. So I'm going to have a quick break. And if you've got questions, okay, put them up and we'll keep going. And if there isn't more questions about the assignment, we're going to go over something quite cool. And I'm going to try something different this time. So anyone that's behind, you can catch up. I'll give you a quick break. And yeah, so I'm just going to Admit peculiar. All right. So I have a couple of questions. So if you have a look at this table here, and then you have a look at oops, didn't mean to do that. Sorry, it's hard to use a mouse and table at the same time. If you have a look at this table, which is at the end of your example, oops, you'll notice that they're the same, except for one's in scientific notation and the other's not. Okay, so that's the only difference. So we've got 40 here, because 40 times 10 to the 1 plus 0, so that's 0. And then we've got 0 minus 8.842 times 10 to the negative 0, and so on. Okay, so this is the total impedance of the resistor. This resistor, there might be multiple resistors. Okay, so you can have things like, someone else asked, can you have R? Yeah, of course you can. It's not always going to be RCI. Actually should be L, but I don't know what I specified on the assignment. I specified I, really should be L, but too late now, it's good enough. So you've got the current for that resistor, and you've got the voltage over that resistor, you've got the current, the voltage over that capacitor, the current over that capacitor, and the impedance of that capacitor, and you've got the impedance of this inductor, the current of this inductor, and the voltage of this inductor, and then you've got the totals. Okay. All right. Is there any other questions relating to that? Okay. So what we might do is something a little different. So I'm just going to set this up. Don't know how well this will work. Just give me a second. Set something up. If there's any questions, ask them now about the assignment. So we'll go on to something different. There we go. Just gonna grab something. Weird. So someone asked, will the columns increase with the number of components? Yes. So if you have a look at the give me a second. I'm just trying to set something up. It's readable. That's quite nice. So yeah, so if you have a look at the example outputs, just do that. Let's do that. It should be nice and readable. Cool. All right. So let me grab the example outputs. So you have all the example outputs, so make sure you look at them. Unfortunately, LMS, you have to do that. So you can see in this first example, you've got R, C, I, R, because I entered 4 components, and I've got a total. In this one, we've got 3 plus the total. This one, we've got 3 plus the total. In this one, we have 6, and we can see it goes all the way up there. Now, one thing I will let you know of, if it is very long, it will go on to the next line. Now, we don't care about that. Okay, if it goes on to the next line, it goes on to the next line. You can't get around that. Okay? Cool. All right. So what I've got here is Notepad++. And what I thought we might do this time is write some code. So I don't think we'll finish this, but let's have a start of it. And we're going to look at some structs. And we're going to have a look at some macros. So I thought a good little example would be something to calculate your current grade, okay? Because then you can actually use it. I like things that you can use. If you've worked out already the assignment, if you're doing engineering, you can actually use it in the next subject. So it's actually very helpful. So I have a open screen here, so I'm just going to hash include io.h, and I'm going to include standard. Okay. I don't know if I'll need them both yet, but it's most likely that I will. And we'll come back up if we need to change anything. So now what I want to do is basically I want to set up a hierarchy. So I'm not going to start with the code. I'm actually going to start with a piece of paper. And what I want is we have, so you have a bunch of subjects. Okay, so you have subjects. Okay. And there's n of those. Now, each of these subjects has a bunch of, let's call them, well, the first thing that the subject has is a name. Okay, so it has a name. All right, so each subject has a name. it also has credit points. Okay, that's pretty common with subjects. The other thing it has is categories. So, for example, for this subject, you might have labs, quizzes, exams, etc. Okay? So, depending on the subject, this is n-dimensional as well. Okay? And each one of these categories, let's call it categories, has a name. Okay? What else does it have? What does each one of these categories have? So I might put an example in blue. So let's say it's PES, 15 credit points, and let's have labs as one category. So if we're talking, we're trying to look at marks in this case. So what's another category that we could chuck in? I mean, another thing that belongs to categories. What's common? What else is there? So these are the names, but what else is common? So we have a weight. So what weight each one of these is. Okay, so for example, the exam has a weight of 50%. The labs have a weight of, I remember, 20% or something like that. No, 15%. Doesn't matter. This is just an example. And we also have grade items inside that. Okay. Okay. It doesn't really matter because this is an example. So labs has multiple grade items. Quiz has multiple grade items. Assignments have multiple grade items. So even though the exam would have one grade item, it's probably good to separate this into another kind of thing. So in here, we can't do that. All right. So in our grade items, so these are my grade items, we probably need a name, yeah, as well. So if it's quiz 1, quiz 2, assignment 1, assignment 2, probably be helpful. Another good idea would be, has that grade item been graded? So maybe a flag to say graded or not. Now, for assignments, is there a weight of each of the grade items? Yeah, so we can probably add a weight. And what I'm also going to do is going to add a mark, maybe, yeah. And I might actually make that another, actually I'll make it a single one, okay? Just because not everything will have a mark because it might not be graded. So a mark has two components really. It has the percent and it'll usually have a comment. Okay. Are we happy with this concept? So I'm basically building up some kind of construct, some kind of structure. Does that make sense? Like, I haven't even talked about the C yet. So I'm going to go back to my code. Actually, I wonder if I can. Okay, so now I want to code this up. So I'm going to use what is called as a struct. Now, what's going to seem odd here what I'm going to do here is I'm going to create a struct for my first thing, which is subject. Okay. Now, this is an array, so I only need to because this is going to be an array, but that's going to be different. The struct is generic. So the struct has a name. Now, a car would be good. An array of cars would probably be suitable for the name. So I'm just going to put car name, and I'm going to say 50 here. Then I'm going to say credit points. What type should we go for? Yeah, that's idea. So we'll call that credit. And we also are going to have another struct. So I'm just going to leave that for now. So one problem that comes about with structs is we have to go backwards if we want to use a struct within another struct. So the next struct is going to be my categories. I'm going to call this category. And in there, it's going to have a name, let's say, and we're going to have a weight. Now, we could go about the weight in multiple ways. What do you think? Float or an int? Both will work. It'll just change our maths a little bit. I'm just thinking how small of increments we want to go. I'm going to say a float might be better here. We can change it later if we don't like it. So I'm just going to go float weight. Okay. Because we're designing this, we're not just following steps anymore. We can go back. And then we're going to have grade items. So what I'm going to do is go back here. And now I'm going to add an array of categories. However, I don't know how long this is. So I'm going to create a pointer to these categories. Now you'll notice that it says struct category and then a star. The type here is a struct category. All right. So it's a pointer to a struct category. And if we use dynamic memory, we can actually create an array of these. Because I don't know how long this is going to be, depending on the subject. Okay. So one other thing that you'll rarely see in a lot of code is constants. So I'm actually going to get rid of this constants. And I'm just going to go hash define max name string, and let's give it 255. So I actually made it a little longer just because it won't make so much difference. So I've got this hash define up here. And basically what that does is through the preprocessor, it will change everywhere it says it sees this with 255. So if I want to change that to 50, it'll change everywhere in the code to 50. So if I decide that all my names are going to be the max length 255, then I can change that in one go up the top of my code. Now, do not put a semicolon after that. If you put a semicolon, it will replace all of these with 255 semicolon, which wouldn't make much sense, would it? So that's one big mistake that a lot of people make. Yeah. So wherever there's a constant in the code, you try and get rid of it. Zeros and things like that are okay, but any number, if you can, put it as a define. So one other thing, variable names, which someone watching may really want to listen to. Variable names for macros are always all uppercase. Your standard variable names are all lowercase. Okay? And try and keep that standard, as we will see, well, you probably won't see it in this subject, but for professional standards, you won't see uppercase very often in C unless you're doing something special. Now, what you will see is actually functions are written in capitals. Now, we haven't done that in our example so far, and we're not really going to worry about it in this subject. But in a lot of standards, the actual functions start with a capital, but it depends on the standard. So try and keep consistent and try and keep everything lowercase, but every define is uppercase. Okay. For example, Java has a different type of standard, and you use camel case, so you'd write credit and then a capital P for every word that follows. But in C, you usually use underscore and this. And you'll see some variations of that when you see a bit of code that I provide you later on. Okay, so we're pretty good with that. So what I want from you is, what should I write for this next one? So put it in the comments. So I want to create this struct now, and this is grade items. so what should go in here? What if I want to- given what I've got here? What would you put into this structure? It's still there. I lost everyone. No, I don't know about that. Not sure. Okay, so this is our grade items. First thing is name. So we'll just do the same thing. Next one's graded. Now, this is just a 1 or a 0, but I'm going to store it in int. There is a reason for that, but I'm not going to get into it. Then I've got my weight, and we decided that the weights are going to be floats. So I'm going to keep that standard, unless we change our mind later. And the grade items are all variable. So what we're going to do down here is create an array of grade items. I've got grade items. Okay, so now I've got a bunch of structs. Yeah, all right. And we can see we've got grade item, which has a name, if it's graded or not, the weight. We've got a category, which has a name, a weight, and a bunch of grade items once we dynamically allocate it. And we've got a subject, which has a name, credit points, and categories. So the last thing we need is this mark. So struct mark, and set should probably be a float. And then we have a comment. So the comment's probably going to be longer than the name. So let's make another macro. Go hash define max comment string length. There, let's make it 5,000. Okay, and that'll allow quite a bit of text for a comment. Okay, and that looks pretty good. I can't see anything too bad with that. So we're happy with that so far. Ah, there's one mistake. Mark. We forgot mark. So we need now you'll notice here that I've got struct, mark, student mark. This space here is included as part of the type. Okay, so we're talking about the type struct mark. This is the variable name. So here we've got int graded, here we've got struct mark, student mark, student's mark. Okay, so this is the type. Okay, and we're creating our own types here. Okay, so our type is now a brand new type called. So excellent question. So yes, it does matter. Okay, there are some ways to get around this, but this, you'll notice the order I put them in. Mark is defined, and then we use mark. Grade item is defined, then we use grade item. Category is defined, and then we use category. If I had it the other way around, let's say I put subject up here, the compiler would go, there is nothing, there's no type called struct category. It doesn't exist. Because remember, it reads down the page. So the order, basically hierarchical, in terms of the hierarchy, has to be backwards to get the types to follow each other. Okay? And that's why I've written it bottom up. I mean, yeah, bottom up. Because if I put this up the top, then it won't know what struct category is. Where if I go down, it does. Cool. All right. So what I'm also going to do up here is I'm going to another constant. Now this may not be true, but I'm going to say the max number of subjects is. Actually, I won't say max. I'll actually just say number of subjects is 4. So this obviously isn't quite true with all students, but we're just saying this for our case. Okay. So we're happy with that so far. So now I'm going to head into main. Now I'm not going to. No, I'm go there. I might start off in main and then I might create a function. Yeah, what I might do is start off in main, and then we'll analyze that, and then we'll turn everything into a function, rather than creating the functions first. Now I know what functions I would like to make already, but without experience, you probably won't know that. So what I'll do in this case is I'll create everything in main, and then we'll break everything out. So what I want to set up is this structure, and I want the user to enter this structure. Okay. So let's say in our case the subjects are set. So I'm going to say I'm going to create a new variable of type struct subject. Okay. So if I do that, I could do something like PES, and I can initialize it to, let's say, PES subject. The credit points would be 15. And the categories are null at this stage because I don't know what they are. Okay. So this is one way you could possibly initialize PES subject. We could also go PES subject dot where are we? Name. Actually, we can't do that because we have to do a string copy. We haven't done that yet. So the credit points becomes 20. Okay, so this dot means that we can access things inside of this struct. Okay, so a variable name is PES subject, the type is struct subject, and if we want to access certain elements within this, we use the dot. Okay. However, would it, let's say, give me a couple of other subjects. I don't know the other subjects to do. Give me 3 other subjects. What's the code? It's not a code. So let's go MLA. And physics, I'm going to assume it's PHY or something like that. Maybe not. And what else do you do? What else do you do? Okay. Okay, so we've got 4 subjects there. Now, that's great, but would it be a better idea to create this as an array? So I can have an array of structs as well. So I'm going to change this, and I'm going to write subjects. And I'm just going to use the square brackets here. Now I've got the number of subjects, so I can just put that in my square brackets. So if I change my mind later, I can change how many. Now I'm going to start configurator. This one's a little bit smaller. It might be a little bit too small. Actually, we don't even need that anymore, so that's fine. So I'm now going to make an array. So I've got struct subject, subjects, number of subjects. And to create an array of structs, I use these curly braces, and I can specify these subjects in between. Now, that looks well and good, but we can kind of make this better. This null here, it's kind of annoying, and it's not really necessary because we're going to set it soon anyway. So I'm actually going to get rid of the null, and what I'm going to do here is write dot name becomes PDS, and I'm going to write dot edit point equals 15. I'm going to do this for all of them because I don't really want that null, because I know I'm going to set it to something soon anyway. So when you initialize, you can, with a struct, you can actually choose what you're going to initialize. My mouse is my computer's running a bit slow with everything running. And this can be really handy. So now I can just get rid of this null. get some more batteries. Alright, so I've got that. And so I've got my subjects, I've got 4 of them, and I've set the name and the credit points to 15 for each of these. Now, one big problem is that what if I go here and change this to 5? Well, then I have to add another one here. So it might be a good idea I just did something. Oh my god, sorry. It's really annoying. It's going really slow. Might just free up some memory. Computer. Okay. So alright. So what I'm going to do here is I'm actually going to just grab all this, copy, or cut, sorry. I'm going to paste it there. And then it's going to write subject information in there. Now this may seem a little weird, but with my defines, everywhere it says subject information, it's just going to replace it with that. So now up the top, if I add another subject, I don't have to go find where the subject information is in the code. I can just add it up here. So I can do things like this as well. I can go hash define, and you can do some pretty horrible stuff with macros as well to make things look bad. But let's say I wanted to do print happy. I'll do printf. I am happy. And I'll put a new, I'll actually put a new line there. Actually, I probably won't because I don't like that. I mean, not a new line, a semicolon, but I actually won't. So what I'm going to do is now in my main, everywhere I write print happy, semicolon, it's just going to print, it's going to replace that with printf, I am happy. Okay? So you can put code in the defines, it could be anything. It just replaces that text. There is special characters in your defines, which you'll learn in the lecture, but I'll leave that for that stage. All right. Does that make sense so far? What I've got there. Just going to track closing some stuff. Way too much open. Everything's going a little slow. Sorry, we're just closing some programs because everything's going a little bit slow. Okay. So that's a bit better. All right. So what I've got here is now a bunch of subjects, and 4 of them. Okay. And they've got this information. So these are constants. In the example that I'm probably going to give, it doesn't actually make much sense to make them constants, but I'm going to, well, we haven't decided how we're going to go about this. I might actually change that a little later. No, actually maybe not. We'll see how we go. So I haven't actually decided what we're doing here. I'm just kind of introducing concepts by application, and we'll work out what we want to do and get out of this. All right, so what I want to do now is I want to start filling these subjects with information. So we've got the name, we've got the credit point, but we don't have the categories. So I want to actually get that off the user. Okay, so what I'm going to do is I want to iterate over each of these subjects. So I'm just going to create a for loop. I 0, I less than, or subjects, I plus plus. Now you can see how macros can be very helpful here, because now if I change this number of subjects to 5, my for loop goes around 5 times and I create 5 subjects. If I change it to 5,000, my for loop goes around 5,000 times and it changes here. So I don't need to go through my code and change constants anymore. Okay? And you'll see this often. This 0, however, isn't a very important constant, so we don't generally give the macro to that. So we're here now. The first thing I need to work out is these categories. So what would be a good idea is to ask the user how many categories does this subject have. So we can go int, say category, and we'll do a print to the user. And we'll say how many categories this subject. We can actually print the name, so I might as well do that. We have the name. Okay. So after I do this, I'll also compile just to make sure I haven't put any mistakes in. So I'm going to now reference my subjects. So I'm going to say subjects I, because I want to talk about the ith subject. I'm just going to say .name, okay, because I want to print that out. And then I'll scan it from the user, set B, and we'll go category. Now at this stage, because we've got a fair bit there, I'm just going to copy this across somewhere. File this. Cool. So there's no syntax errors. So that's perfectly fine. So let's actually run it. So how many categories does PES have? So 5. How much does LNLA have? 2. How much does physics have? 3. How much does BP have? 2. Okay, so looks pretty good so far. It works and does what we want. It's going through every other subject and it's printing out the name of each of the subject, which is grabbing from our subjects. Okay, so subject 0.name would be PES. NLA, EHY, and EP. Okay, so that's pretty cool. But now we've got to create these categories. And I know how much you enjoy dynamic memory. So that's basically what we have to do here, because this is decided at runtime. So I'm going to do this two ways. I'm going to create a variable called category. I'm going to make it a pointer because I need to store a pointer. So now I've got a pointer to a struct category. Okay? And this will be the start of my array of categories. So we have a bit of a problem here. So my question to you is, I'm going to take a quick break. What should I put inside this malloc if I want to create a bunch of categories? Okay, so it's the same as before as using size of, but what's the size? What's the type? What do you times it by? So I'll be back in a second, and I want you to answer that and have a good go. So don't just say I don't know. Have a guess. And this is actually really important. But yeah, I'll be back in a couple of seconds. Okay, they were pretty bad guesses. So it's basically the same as before, except for we have size of struct category. Because our type now is a struct category. And so we have an array of struct categories. And then we just times that by category count. Okay. Now, the size of here may not be what you expect it to be. So if we have time, I might do it on Saturday actually, we'll talk about structure padding. So in a lot of cases, you would expect this to be a certain size when you calculate it by hand, but it actually won't be the right size when you actually go and view that value. And we'll go have a look at that next week, or on the weekend, or if we have time later. Okay, but it doesn't matter. And that's why we use the size of, because we don't actually need to know the size. It'll calculate it for us. But it is something to be aware of, and something kind of cool as well. All right, so we now have an array, a dynamic array of categories, depending on how many the user put in. So I need this subject pointer to point at that. So I'm going to say subject I dot categories is going to become categories. Now you notice that the names are the same. It doesn't really matter because this is of type struct. It's not of type struct. It's in the struct, so that name is a member of subject, where this is just a normal variable, and so they can actually have the same name. So that's all good, except for I see a bit of a redundancy here. So I've got struct categories, and we're setting that to categories. So, and I've also got this categories here. So I might actually draw the box and pointer diagram at this stage to see if we can remove some of this redundancy. So I'm just going to what I'm going to do is put that there. And I'm going to come back to my Photoshop. And we're going to have a look at main. So we're now in main. And I probably need a lot more room. Actually, we won't. And the pen's frozen. All right, so we're in main, and we create an array of struct subjects. So this is going to be kind of difficult to draw. So we'll start off with one. We'll see how we go. So our array is called subjects. It's an array, and we've got subjects. There's a pointer to the start of the array, and its type is of type struct subjects. Okay, and we know there's 4 of them. All right, and we're probably going to run out of room here. Now, we have inside this a bunch of variables. So for each of the subjects, they have their own variables. So I'm going to draw this like this. Now we have name, which is also an array. So it's going to be, and that also has a pointer to it. And that's type car. We then also have credit points, just type unsigned int. And then we also have our category pointer. So this is categories, which is of type struct category star, and that's a pointer to something. And then we have that for over. I'm not going to write them all out. So you can see this is starting to get a bit complex, and what we have in here is PES. In credit points we have 15, and then we have a pointer going somewhere. Okay, so each one of these struct subjects has a bunch of information. So it has a bunch of variables inside it. And each one of these would have the same thing. So if we did the second one as well, it looks something like that. And then it'd have all the characters. I'm not going to write all the characters out, and so on. So we come back down here, and we've got our I variable, which is great, which is an int, and that starts at 0. And we have a category count. So I'll just call it CC, and that's an int. Let's say there's 2 categories. Okay, it's a bit of an easy subject. Okay, so the user entered 2. So here we now create another pointer called categories. I'm just going to write cats, and it's a type struct categories star, and this points to some dynamic memory. Okay, and that's out of scope because it doesn't have the same scope because it's nameless. It doesn't really matter where it is on the diagram. And with this, we are creating a bunch of struct categories, and we set 2 of them, and each of the categories has a bunch of stuff in them as well. So the first variable is the name, okay, and that'll be in the name of the subject, and then we'll have what's the next thing? Weight. There's a float, and then we'll have another pointer to the grade items. Okay, and that's the type struct grade items star, and the same for the second one in the array. And this will be a pointer somewhere as well. Okay, currently it's, I don't know, but it is a pointer. So that's our malloc there. That's our category variable, and it's pointing to this massive array of structures. Okay. And then I grab categories, so I grab the value of categories and I store it here. Okay, so this is now pointing to the start. Okay, now where the start is going to start getting very confusing. And we have to have a look at memory, and we'll have to look at padding as well. Okay, but some interesting things to note just before we go on. If I do pointer arithmetic on this categories, it's not going to point to the next thing in here. It's actually going to point to the next category, okay? Because it's of type struct categories. So it's going to jump over to here. Okay, and we'll have a look at the memory stuff next week or another time. All right? So I can see a bit of a redundancy in that this is kind of redundant. I don't really need that variable because I can just store that straight in here. So if we go back to our code, we could just write get rid of that and just do that. And now we just have a pointer from our categories. So that just basically eliminates that, which wasn't really necessary because we've got a pointer to the start anyway. Okay, so once we start getting into structs, these box and pointer diagrams become way too difficult to draw in a lot of cases, unless you're using some computer-aided tools to do it. All right, but does that make sense so far? Okay, so we've got a pointer to a struct, and it's a struct array dynamically created. And structs have a bunch of stuff in them rather than just one variable type. Okay, so just say yes if that makes sense. Yep. All good? All good. Okay, so let's go back to our code. Where did I put our code? There. All right. So we've got our categories, we've got our malloc, that looks all good. So what should we do next? Well, we probably should grab the values for all the categories. So the name, the weight, and the grade item. So we're going to have to go even deeper. So if we're going to have to iterate over categories, we need a new iteration variable. So I'm going to introduce J because we're 2 levels deep. And we're going to go for J equals 0. Now, this isn't a constant, so this is just going to be category count. And we're going to go J plus plus. Okay. We have our categories. We're going to iterate over these. Now, one other thing I should do is really set the language. That's a bit better. So in this, we now need to have a look at the categories. So the first question you probably want to ask the user is, what's the name of the category? So let's do that. Printf does that make sense? Okay. So now what I'm going to do is grab a string. we could actually use some string functions here to copy it, which would probably be a good idea, but I'm not going to. So I'm going to grab a string and I'm going to store it at. Now, we have our categories and we have our subject. So now I need to go subject I dot categories. Oh, away. Categories J dot name. Okay, because we don't. We're talking about the ith subject and the jth category and its name. Then we want to, let's say, well, the next thing is the weight. So what is the weight of category let's put a string there. And then we can get that from the user as well and store the result somewhere. So this would be a float. And here we need to put weight. Now, there's something wrong. We need the address. Okay, we didn't need the address here because it's a string. So this is a string, so it's a pointer, so it's perfectly fine. But here we need the address. Now, with a struct, we're talking about the address of where this weight is. So we need to find this and then get the address. We don't want the address of the subject I, and that doesn't have it. The address of this is not a structure, so it's the address of this whole thing. Okay. So, well, the next thing is the grade item, so we might leave that and we might compile and check if everything's working at this stage. So we'll just copy that. Paste that. Well, don't put any warnings or errors. Oh, yes we do. So I put subject here. That should be subjects. I've done that a couple of times. Cool. Let's see. That fixes some of the errors. Oops. And we're missing a directive here. Okay, so the other thing is that we forgot to put the name here. So let's do that as well. So let's see if this works. Hopefully it does. So I'm going to run that. So how many categories does PES have? Let's say 2. What is the name of, we probably should actually say what is the name of the ith category or jth category. Might be handy. So I might actually change that. And I might put some better spaces in as well. If we're going to use question marks, we probably should be consistent. So what is the name? Let's say exam, because we all love that one. And what is the weight of the category exam? So let's say 0.5. And then we ask for the next category. So yeah, I think the ith would be good here. So let's say labs. And then what is the weight of the category category labs, let's say 0.15. And then we keep going. So what does NLA have? Let's say 1. Let's call that tests. Let's say it's worth 100%. Okay, so I'm just going to exit that. Let's fix up some formatting. So a question mark there, space there, I'll put space there. And what I'll do here is I'm going to put %d, and I'll change this to j+1. That might make it a little bit nicer in terms of the way it looks to the user. I don't want to save that. Actually, I don't really care. All right. So, what's the next thing I should do? We might look at pointer arithmetic in this again with structs. So, what's the next thing I should do here? What haven't I initialized for the categories? Oops, so what do you think we need to do next? So this is our category. We've handled the weight and the name, so what else do we need to handle? It's still there. The grade items. We haven't got to the marks yet. Marks are still very deep. So we've got to create these grade items within it. So we're basically going to do the same thing as before. We're going to do a nice malloc, but we need to know from the user how many. So I might actually just copy paste that. I'll copy paste the whole thing. And now we're talking about grade item count. And we're going to say how many grade items does the category %s have. %s is going to be this. The category. And then we basically grab that number. And this time we've now got .j grade items. And so here we now are talking about struct grade items. So let's change this to size of struct grade items. And then we get the grade item count. So now I have an array of grade items as well. So we're building this up. So we've currently got this, we've currently got this, and now we also have this array. Okay, so we're getting close to the end. Okay, so we just created a grade item count. How many grade items does the category have? And then we scan whatever the user enters, and then we create dynamically a bunch of grade items. Okay. Does that make sense so far? Cool. All right. So now we have to go through all the grade items and fill that information in. So I'm going to need K to do the next for loop. So I'm going to say, I'll just copy and paste. Copy and paste to make sure it's consistent. Output, and I'll just change that to grade item. Output, and I'll change this to K's. Okay. So now I've got my next loop. Now, grade items is a pointer. So I can do something like this. I can go K dot I don't even know what is there. Let's say weight, and I can set that to 4. Okay, but I know that you'd much prefer to do pointer arithmetic. So let's do that instead. So instead of using these square braces, I'm going to use pointer arithmetic. So here, we know that it's going to increase by the type it points to when you add 1 to it. So the same system applies. So what I'm going to do is I'm going to go a little bit further up. I'm going to go here. I'm going to go struct, grade items. So I'm going to create an iterator or a pointer iterator. And what I'm going to do from that is then just grab this pointer to the start of this array. Okay. So this is like the assignment, and like in the lab this week, and like in the example I gave last week, or 2 weeks ago. We create a copy so we don't lose the start of the array. Okay, so we don't want to lose the start of this array. So I create a copy, and then we get in here. So let's have a look. What do we need for our grade item? We need the name. So let's just grab some of this stuff. So what is the name of the kth grade item? And then we need to scan, but we're using a pointer in this case. So where am I? So we've got grade items iteration. So I'm going to put this grade items here. And in this case, obviously I need to dereference this and then go dot name. Okay, because this here is a pointer, so I need to dereference it. Grab the struct grade item and then the name. However, there is a shorthand notation for this. So when you're talking about a pointer, you can grab what it's pointing to and the value, so dereferencing it by using a dash and then the little greater than symbol. Okay. So let's have another look at the next example. So what else have we got in grade item? So grade item has a weight as well. We might do that one first. So we're going to steal this. So what is the weight of grade item? Sent S. So we've got the name. So we can steal this. Okay. And then we need to grab this. Now you'll notice that here we need the address because we're talking about a normal variable, not a pointer. So I could do a couple of things here, but let's go with the easy route. And I'm just going to put weight. Okay. So because this is a pointer, it will grab the weight and then it will dereference it. Okay. So this little slash, like a little arrow symbol kinda, is just changing it from being this. Now the brackets are incredibly important if you decide to do it this way. Oh. So that is the same as okay. So these two are the same, right? Because grade item iteration is a pointer to a grade item, we have to dereference it, then grab one of its elements, which is weight. Or we can do the shorthand notation and just use this little arrow symbol. Okay. So we're getting somewhere. Now we have to ask the question, has this been marked? So has grade item centers been rated? Oops. Okay. Now with this, I'm going to assume that the user enters something valid, but we need a variable. So let's just say, I'll just limit the scope. So I'm going to limit the scope of this variable because I only need it for a short time, and I'll just call it and what I'm going to do with that now is basically I want to ask the user, so I'll just scan F, C, %C, sorry, and I'm not going to bother validating this because we'll just complete the code at this stage. So what I want to do with this is basically, we'll do it the long way. So if input equals y, or input equals y, okay, so we've got two cases. It's a binary case. We're just assuming if they enter something invalid, we assume that they're stupid, and it's basically we don't care. So if the input is a yes, then we might as well set this graded to be, what's it called? 1, let's say. Is that how you spell it? And if that's not true, I'm going to set it to 0. However, I don't really like that because now I'm introducing constants into my code. So what if there's another state? What if there's graded 1, 0, 1, and 2, and maybe 0 is not graded, 1 is there was plagiarism, and 2 is that it's been graded, or 3, it's a special consideration or something like that. So I don't like having these constant values here. So what I'm going to do is introduce some more macros. Find graded, it's a 1, and find is a 0. So now I can use these instead, and this gives a bit more meaning here too. So if someone read this, they don't have to work out what 1 or 0 means. Okay. I also want to do something about this student marks. Actually, we'll leave the student marks for now. That looks pretty good. And then all I need to do at this end stage is grab my iteration and increment it. Okay, so let's see if I've made any mistakes. So copy that. It's that. Let's see. Oh, no mistakes. Cool. Well, let's see how this goes. So how many categories does PES have? Let's say 3. What is the name? What is the weight? 5. How many grade items? Say 2. What is the name of the first grade item? Let's say written part of the exam, and that's worth half of it. So you'll notice we've got a problem here. So let's go back. So what's wrong here? This one you should be able to answer. What have I missed? Or what should I do to fix this? If you don't know, just say don't know, but this is something very easy. Okay, so remember, it doesn't deal with the it's going to grab any character. So we just put a space in the scanf. And we've seen that heaps of times. Or we could use a get guard beforehand. Why do I get this instead? Okay. So this is looking pretty good now. What I might start doing is, just for safety, because we're starting to get quite a few variables up, I'm just going to go down the bottom here and start freeing some stuff. So I'm going to free the categories. I'm going to free the grade items. Because they're the only things that I'm not looking. Yep. And I might turn success. So it's successfully finished. So now we've got one more thing, which is the student's mark. So if it hasn't been graded, what should I set this to? What would be a good value? So if it's not graded, if I go grade items ITR, I've already forgotten what it's called. It's called student marks. If it hasn't been graded, what would be a good thing to set that to? Would it be a good idea to set the values to 0 in the student marks? Or would there be a better way to go about it? So this is just logic. Well, let's have a look at this. So what about let me think. We could set it to -1. Has anyone else got any other suggestions? So we kind of have a bit of a problem now. We could either leave it uninitialized and just use that graded variable. I think what would be the most suitable, however, is because we know that it hasn't been graded, if we wanted to calculate the total marks, it'd probably make most sense to make that 0. Because then we can still calculate everything. If you set it to -1, we're not going to get any good calculations. So because we've got the graded, we can either omit it if we need to, but we probably just should set it to 0. That's what I'm thinking. You can disagree, but I think that'll help us in calculating everything. So let's go student marks. Now, this here was a grade items to a student marks. Now, I'm going to put a bracket around that. Because we've used this little arrow, we've dereferenced the grade items and we've got the student marks. So we're here. Now, this to here doesn't need dereferencing now because we're not talking about a pointer, we're just talking about an normal variable. So I should be able to do something like point becomes 0. And I might just you haven't done string functions yet. So we also have the comment. So I'm going to use another function, and I'm going to write string copy. And what I'm going to do is for this string comment, okay, what I want to do is basically set it to blank or something like that. Set it to set it to blank. Single space, that might be nice when we print it out. So we have to use this string copy here because we can't write something like car A and then write A becomes text. It won't work. The only time you can initialize a string is when you initialize it at the start. So we actually have to use a copy, and you'll learn about some of the string functions. However, now that I'm using string functions, I have to go up the top and include string.h. So what's the last question we need to ask? So if it has been graded, what information do we need now? Now I think we've got everything at that stage, which is kind of nice. Then we might just print out a nice little table for now. The student's mark, exactly. So what we might do is something like, what is the student's mark percent of grade item? So that's that actually works out well. And then we can just scanf that input. And it's going to be a float. Now, this one's going to be a little bit more tricky. So we have this whole percent in here, and then we also need the address of this. And have another set of brackets around that. I am wondering Did I just lag like heaps? I think my internet just crashed for like 2 seconds. Hopefully it didn't crash the stream. So it's still working. Yep, okay, sorry. I don't know what happened. Something happened. Alright, so that looks pretty good. What else should we get? The very last thing that we need. No, I think we've got everything for our function. Oh, not our function, our program. And then we might move all this to a function, I think. Because this is kind of bloated for their name. So we also need the comment. You know what else we could do? So I'm going to put %s here, and I'm going to put a macro. So find name, call it Harry, and I can just put a student name in there. Make it a little bit nicer. Let's put a Harry's mark of then we can ask for a comment, and we can scan that in as well. So use %s. We don't need the address because we're talking about pointer in. Strings are pointers as well. These are arrays of characters. And then from there we need comment. Oh, I made a big mistake. That makes no sense. Get all this information here through. Okay. That's looking pretty good. So copy that. And let's see if I've made any mistakes. I might have. Okay, so the first mistake I've made is this should really be string, because we want to print it as a string. So let me fix that one up. I'm missing a bracket. Yeah. What I didn't like about. And 107. So we also have a problem here. And this is, so I'm actually going to get rid of those and then we can chat about that. Let's just check that everything else is working first. So everything else is working. So how would we go about freeing this memory? Yeah, in a for loop. So we need basically this. However, we have one big problem. So the I one is quite easy, but we don't have the number of categories. Okay. Now, what I've done is I've got a dynamic array, but I don't quite know how long it is. So it's kind of unreliable. So what I'm going to have to do is, in subject, I'm going to have to introduce a new variable. And this is going to be int categories. And same within categories, we're going to have to say number of grade items. And that one's just a single. So now I can know how many times to iterate for a particular subject. So now I can start getting rid of some of these variables because I don't actually need grade item count anymore. I can just say subjects dot so I can just go subjects I dot number of categories. Yeah, I think that should be good. Bracket there, there. It keeps deleting my brackets. So now I'm going to actually store the number of categories. So, and I made a mistake. That's actually the wrong place for that. I'm going to copy that anyway. So that should go here. And then we can just delete that category count because we don't need that now because we've got the number of categories. However, because we've deleted that, we can use our variable here to grab the number of categories. So our code's getting a little bit more concise, but also a little bit more complex. Okay, so we've got that. Now I've lost what I was doing. Ah, yep. So we need grade items as well. So subjects dot categories j dot number of grade items. So we can get rid of this grade item count now. And we need to ask for the address of this because and the scan there wants the address. And once again, rather than this grade item count, we can now just use our structure to tell us how big this is. Okay, so now I've got the number of grade items. So that looks pretty good. However, we've got another problem. So this could be really bad, and we'd actually find that well, actually, let me do it first, and then let's see if you can see why this is really bad. So I'm going to do this. Ooh, and I missed something. It's going to give me an error. So you'll notice that there's category count here, which now I'm using this. Let's change that one. And the same with this one. So let me grab that as well. That one. Okay, so that should work now. So I'm going to now have to use the number of grade items. I just need the number of categories. So in here, I'm just going to go to categories. Now I don't actually need the number of grade items because it was free from the start of that. But while we're creating the other one, I thought it might be a good idea. So, can you see a problem here? So I'll give you a quick, I'm going to have a quick little break. See if you can see the problem with this free here. There is a little bit of a problem. I'll be back. Okay, so first thing is the in J is fine because it's inside the loop. Because J only has a scope between here and here. So that's perfectly fine. The other person actually is correct, but they've talked about the wrong things. So the problem here is that, not that I've freed the subjects can't be freed because they're a constant, okay? So it's a fixed array, so it's not dynamically allocated, so I can't free that. It's the categories that I free before the grade items. So I freed the categories before the grade items, so I can't access the grade items. So this really needs to go here. And now that should be fine. So this all looks a bit ugly. So let's first test it, just to make sure that there's no other mistakes. All that. Somehow I missed a semicolon here. Across. Save that. No errors or warnings. It's beautiful. So let's say, how many categories B? Let's say 2. What is the name? What is the weight? Let's say 5. How many items does this have? Let's say 2. Have 1. Where's the weight? Let's say 1. Let's say no. And then let's say like 2. And then we give us the weight of 0.1. Has it been graded? Let's say yes. What's Harry's mark? Let's say. Now we could go about this a couple of ways. I'm going to go 6. What's the comment? Okay, so we have another problem. So let's go back and fix that. Okay, so we can see we've got a problem somewhere in our code, and it's around the comments. Thanks. So let's have a look. So comment is a string, so that's fine. So for a grade iteration, we haven't introduced any variables except for input, but we don't need that until we come back. So what I'm going to do is place the string shouldn't pick that up there. I'm a little confused. That should all be fine. That's not a pointer, so that should be fine. That's the only percent C that I've got. Can't actually see what the problem is. I'm going to try that again. We should write the code again. I don't think that's a good idea. So, we have a little bit of a problem here somewhere. So, it's all the right time. Oh. I think it may have just been me. Which way? It was just me. I think I entered something incorrect. Because we're not validating. I think if it's not with the code, it's just with input. I think. Let's have a look at this. So how many categories? 2 labs, 0.5, 2, 1, weight, 0.1. Let's go to something greater, yes. Yeah, that's a percent F, so that's fine. 10-1. And the comments. Okay, so that's working. I must have accidentally put a character somewhere when I did it last time. Lab 2, the weight, weight 2, has a grade item being graded, yes. Let's say 0.2. Yeah, so that's fine. I must have just accidentally entered that character. And how many grade items? 1. Exam. What is the weight? 100%. Okay, and then we can go on to NLA and so on. So let's just say 1. That's the 1 character exam. 100%. That's 1 category exam. And the weight is 1. And it hasn't been graded. So 1 is the name. Let's say test is the weight. So 0.5. How many categories does test have? Let's say 1. test. What is the weight of the grade of the big test? Let's say 0.6. Let's say yes. So they got 0.2. So add and 1. What's the name? Testing. What's the weight? 5. How many items? 1. What's the name? 2. What is the weight? So let's go 3. Okay, so it didn't crash, it didn't break. And that's collecting all the data. So we're happy with that so far. You could use an Excel spreadsheet, but there is a lot of power in this. And let's say you have 100,000 students and you try to calculate their grades. You wouldn't be using Excel. You're way too slow. If you did 0, then it'd just be 0. If you do 0, however, I'm pretty sure null returns a null pointer. So basically, if you set it to 0, it'll actually work. It'll act as a null pointer, which is still a pointer, so you can still free it. So there's no problem with setting it to 0. malloc will still work. It just returns a null pointer. So you can deal with that, but however you like. All right, so I think what we'll do now is make a function for that, and then we'll continue with this and make it a little bit more powerful and automated. Because what I'd like to do is get this, put it into a file, and then we can calculate the grades automatically. So you can put all your grades in and we'll get them to calculate. So what I want to do now is create a function. So we could go about this a couple of ways. I'm thinking something like get marking information. Now, I don't really need the subject information because the subject information's there. What I really want is everything else. So what I want to do is I want the information returned to this struct. So I'm going to need a pointer. That's pretty much all I need. So that's my function prototype. I'm actually going to move it above structs. And I'm going to copy that, bring that down here, and subjects. And I'm going to basically put that, oops, basically I'm going to put this function in here, and I'm just going to pass my subjects in. Okay. And then I'm just going to grab all of this, which I've had in there, and then just return this I. Oops. I also need this I for my freeing of everything. However, we can probably do a function for that as well. So let's see if that's all good. I haven't made any mistakes. I have. Set up a mistake somewhere. So firstly, we need a pointer. That is the address of that. The other problem is that truck subject doesn't exist unless it's below here, because I haven't declared it. So fix that up. Now, the other problem here is we actually have yeah, that's my fault. I had that right. Okay, so that all compiles perfectly fine. Obviously, I don't need the address because subjects is a pointer to this array. So now we've got that nice function there. And I'm actually going to create another function, which will just be subject. And we'll pretty much just copy and paste that. Yeah, that looks pretty good. So I'll just copy that. Oops. There. I don't like putting names in these. And then we just need to call this function in name. And just pass subjects in. I think this looks pretty good now. Yeah, so that all works. And that all compiles perfectly fine. So we've just, the reason we've separated this into functions is because now we can use these functions and they're more meaningful. So we've reduced main to basically 4 lines of code now. And now in between here, we can start calling other functions and dealing with those. Okay, but we've got a fair bit of code written, which is nice. And we can start using this in future help sessions. So my question to you is this helpful to go about it this way, or do you prefer just small examples on Photoshop? Or do you prefer going through a full code and making it as you go? Or would you just like me to write a bit of code and then we go through it? So the advantage of going through it this way is this is kind of what you're expected to do. Okay. So when you get to the last assignment, you do stage 3, you're just going to be left to work out the problem yourself. So, and in real problems, you're just given the problem. So when I started here, I didn't know what I was going to do either. And I kind of just went with it and tried to solve the problem and make it work. So the reason I thought this would be good is because this is more coding than just theory. Because, yeah, if you actually want to do coding, it's not going to be small problems. It's going to be you have to solve the problems. And yeah, this isn't perfect and it's still not optimized, but it's a nice way to go over a bunch of stuff and how you should think about problems and different ways you could approach it. Yeah, so we can do a bit of both, or we can just go back to small examples. But I think we also got through a lot more than we would with small examples because you have well, next week's all structs. Let's see. Let's see. So next week's lab looks something like this. Not like this, but it's full of structs and multi-level structs. So what have we got? Let me see what I've got left. Yes, so this week we're doing strings and dynamic memory. Should have been last week. And this week we've got structs and preprocessor. Preprocessor is fairly easy. There is more to defines, so if def and stuff like that. But getting this is probably the most important part for now. Structs you need to understand quite well, especially for the last assignment and for next week's lab. The week after that, we'll start looking at files, which is not too bad, and command line arguments, which isn't too bad. And then header files, they're fairly confusing, but not too bad. And then we'll do testing and debugging, which should be fairly easy. And then we'll look at flowcharts and blocks and pointer diagrams again in the last week. So nothing overly complex. Structures are not as hard as pointers or anything. It's just another type. And it's just generating your own type as you sort. It's just the same stuff we've used in the past. It's just that we're using this grade item, not grade item. We're using these structures to do stuff rather than normal variables. And we can do all the same stuff as we did before. So yeah. The other thing with structures is that it gets hard to do small examples with them because it's a structure, so it's a big concept. So to show how this would work in a small example, it's still going to be a couple of long bits of lines of code. And next week's lab, if I grab it up, which I haven't updated yet, which I'll do this weekend. But it's not as difficult as some of these ones because you're not dynamically allocating, but you do in the last assignment. I think, yeah, you are dynamically allocating in the last assignment. Two-dimensionally as well, which would actually be a good topic for next week's help session, this weekend's help session, because that's a really interesting problem and a real fun problem. So yeah, we might leave that there. Because you can see even drawing the box and pointer diagrams gets a bit tedious as well. Instructions. All right, so any final remarks or questions? That's all right. Yeah, I thought I'd try something different, especially with structures, because I did not want to have to draw a million big box and pointer diagrams out. Get Buddy to wolf. He's not in here, and he doesn't wolf just because you tell him to. He can't read it. All right. Well, thank you very much for hanging around. And yeah, I'll see you in the lab. Catch you guys.